So this is going to be a video for problem number 2 off of note sheet number 7. Okay, so if you watched the first video, you saw an introduction to how to solve these problems when you are dealing with non-exact degree values. Okay, so same set of directions. We are looking for possible values from 0 to 360. So obviously we know we're answering in degrees. We're rounding off our answers to the nearest tenth. If needed, it's going to be needed, okay? And problem number 2, we have the same problem as number 1. We have both sine squared and cosine squared. And unfortunately, you can't let that be, okay? We can't factor it as it's written. We can't combine them as it's written. So we just have to deal with it. In problem number 1, I replaced sine squared theta. In problem number 2, for giggles, I'll show you that you can place cosine squared theta. So remember, sine squared theta plus cosine squared theta is equal to 1. So if I solve for cosine theta, or cosine squared theta, let me be specific, I would get 1 minus sine squared theta. So let's see what we've got here. We have 3 plus sine squared theta is equal to 6 times 1 minus sine squared theta. All right, little distributive property here on the right side. So 6 minus 6 sine squared theta. I'm going to move my sines to the, or my sine squareds to the left and my constants to the right. So 7 sine squared theta equals 3. Divide both sides by 7. All right, take the square root of both sides. And as soon as I say take the square root, as soon as you put a square root into a problem, remember there needs to be a plus minus here. Okay. And clearly, all right, if we stop here for a second, we know this is not going to be an exact answer off the trig charts. All right, so don't go there, don't think about it. All right, I'm just going to focus on one of the positive answers. So positive root 3 over 7. To get theta by itself, I'm going to take the inverse sine of root 3 over 7. Remember, these answers are supposed to be in degrees, so make sure your calculator is in degrees. And I am getting theta as my reference angle, theta prime, is 40.9 degrees. Okay, so that's what I know my reference angle is. So you guys know by now, if you watched enough of these, A, S, T, C. In quadrant number 1, I have a 40.9 degree angle. And I want to figure out which of these quadrants are going to have angles that I need to find. So back here, right, sine of theta was equal to both positive and negative root 3 over 7. So where is sine positive? Sine is positive in quadrants 1 and 2. Where is sine negative? Well, sine is negative in quadrants 3 and quadrant 4. So as with problem number 1, I'm going to need 4 angles, 1 from each quadrant, to satisfy this equation. So in quadrant 2, I need to find that angle that is 40.9 degrees off the x-axis. So the x-axis, remember, is 180 degrees in between quadrant 2 and 3. So take 180 minus 40.9, 139.1, I think. Yeah, 139.1 degrees. Let me make sure I double check that. Yes, okay. I need an angle in quadrant 3 that is the reference angle, so 40.9 degrees off the x-axis. So 180 plus 40.9 Okay, so 220.9 degrees. And I need an angle in quadrant 4 that is 40.9 degrees off the x-axis. So full rotation would have been 360 degrees. Okay, so if I take 360 minus 40.9, I'm going to get 319.1 degrees. So if I collect up all of these possible theta values here, all right, so theta is equal to, in the first quadrant, 40.9 degrees. In the second quadrant, 139.1 degrees. Third quadrant, 220.9 degrees. And fourth quadrant, 319.1 degrees. All 4 of those are the answers that you want to make sure that you are including. 2 of them from quadrants 1 and quadrant 2 are where sine is positive root 3 over 7. And 2 of them, quadrants 3 and quadrant 4, are where sine is equal to negative root 3 over 7. Okay, so that takes care of problem number 2. I'm going to go ahead and cut this video. I'll make some other videos for 3, 4, 5, and 6 so you can see those as needed. Please, guys and ladies, if you have questions, let me know.